Hey guys, welcome back to the channel. I have another ECM repair, this time working on a 2004 2500 Cummins computer. This is a 2004 Dodge Ram 5.9 diesel. This is from Joe K in Michigan. He has a no star, no communication. He said he checked powers and grounds to the computer. Everything was there, but the computer was not communicating. All right, so I got everything connected. Let me show you. Well, first, if you have any computers to send any instrument cluster for repairs, please visit my website, Mike Salazar Diagnostics. And this is the way my name is spelled, M-A-I-C. It sounds as Mike. You have all the contact information in here, the address and everything. You can click the contact button that will open your email provider or application in your computer or in your phone, and then you can send me an email. You can also use the last chat, or there is my phone number right there. That's the easiest way to contact me, and then we can start the process of getting your computer here to be tested. All right, so I got all the information ready to go. Let me put the connections and everything that we need for this computer. So I have everything already marked in the computer. This is the same computer that we have here. I have already marked in the connectors so I can see from the back where I need to do the tests. I have powers and grounds, sensor grounds, and voltage supply as the 5-volt reference. If it's a CAN high or CAN low communication, or if it uses, like in this case, uses these pins, the DLC7, DLC12, and DLC2, based on the bin number. So um, I will just keep that in there. All the numbers on powers and grounds and everything is right there. As you see, well, powers are in 20, 30, 40, grounds in 50, and all right, as I was saying, grounds in 50 and 49. This is in connector 2, which has only 50 pins. Connector 1 has 60 pins. I have all the pin outs in here, so I always corroborate, make sure that everything is correct. And I am, connecting the computer the correct way. We can see, all the pins in here. I'm going to scroll a little slow so you have that. In case you need it, just please, text me an email. I can always share that information. And let me go over to connector 1. Again, it's 60 pins. Let me just go over to the next page and then scroll down. This is where most of the actuators and sensors are. I also have to corroborate to make sure my connections are correct. Pin 7 goes to connector 2, pin 16. That is exactly how I have here. 12 on the DLC goes to connector 2, pin 19. Again, that's it. And then pin 2 on the DLC goes to connector 2, pin 28. And that's exactly how I have it. I also have a multimeter connected to the sensor ground and sensor power, which are in the connector 1 and pins 54 and pins 32. All right, so this is my connections in here. I also have to see if we have communication. Let me put this in here and put the oscilloscope. I got the oscilloscope ready. I got the blue channel, as it says in there, blue channel on DLC2, red channel on DLC7, and the green channel on DLC12. All those settings as 20 volts, and I have, just to start, 1 milliseconds per division. All right, so I got also the scanner connected and ready to go. Let's power up the computer first. I got the power supply connected and ready. Now let me make sure that this is on. All right, let's power this up. And okay, first time, as he said, I don't see 5-volt reference, which is no good. The oscilloscope is running and I don't see any communication. Let me take the trigger. When you have or you don't know the amplitude of the signal that you are catching with your oscilloscope, remove the triggers. When it's no triggers, it will catch anything that is in there, because if you have a trigger and you have it not in the right height, or where is the signal amplitude, let's say 5 volts, 7, whatever, it might not show up because your trigger is too high or too low, right? Well, too high. All right, so definitely, I don't expect to have communication. If I remember correctly, these computers don't communicate, like they don't read the pin. I had to actually manually select it, but let's try this for my records and his as well. And then we do a little bit of a testing with the same image that I have here to see what the voltage rails are. I can definitely see the scanner is trying to communicate, and then definitely nothing happened because I saw the red channel going up and down as far as voltage, and that voltage is coming from the scanner trying to communicate. All right, so we are going to skip this. We're going to go when you cannot select the vehicle in auto and the automatic mode with the Phoenix. You can go over to scan. We're going to go into American, and we're going to select Dodge. And here, just open the Dodge software. This is the Phoenix Max from Tap Done. All right, so it's a 16-pin connector. We're going to do selection of Dodge, and we're going to go over to 2004. Oops, sorry, I think I selected 2006. 2004. Ram truck. Yeah, this is if you have a Sprinter. So we're going to go over into the PCM, and we're going to try to communicate. Let's see what is happening. I'm going to change the time base a little bit so we can see what the scanner is trying to do, because I can see the red channel voltage changing. You see it's sending a signal. The scanner is like, hello, is somebody there? Remember the red channel is impedance 7. Now we see something on the green and then the red, 7 and 12, nothing happening on pin 2, and we see no communication. All right, so definitely 100%, Joe, I can reproduce your concern. All right, so let's try to do a little bit of a test. Let me move the scanner out of the way so I can carefully do this test. We should have 12 volts in here. So I'm going to change the hands so you guys can see the result on there while I'm touching. I need to move this. Give me just 1 second because I don't know. Oh, I cannot see that in there. Trying to move the computer so where I can see. Okay. I'm going to try to touch these two capacitors here. We got 13 volts in that one and 13 volts in there. So we got 13 volts in that one. Let's see here. I don't see voltage, so you can see that. Let me go to the next pin. Yeah, no voltage in there. So partially power up ECM. This is good. At least we got some voltages. I don't think we got everything the computer obviously needs to be working. This should be 5 volts in here, and we got a 0, a hydrolytic capacitor, like the aluminum type of capacitors. The line will be the negative. On the tantalum, that means power. And if I touch in here, this should be just a ground, and we can see 0. This should be a 6 volt, and we got 0.1. So yeah, the computer is definitely dead. I'm gonna have to poke around and see if I can make this computer work. I actually have better hopes when I see something like this than when I have a computer like this one. I don't know if you saw the last video. I think it's not, well, the last one on this type of computer, that the computer had all the voltage rails, but at the end ended up being a bit microprocessor. I have extensive time testing these computers, and I have mapped out pretty much the entire computer. I know these computers really well. All right, guys. So, Joe, I will be contacting you first. And then definitely, I have to do more tests and make sure that can be repaired. And then I will contact you with a repair estimate for your approval. Thank you so much, guys. If this is not too long, the repair, I'll probably just repair the computer and then add it to this one. So I'll be right back. All right, guys, I am done with the repairs. I mean, it was very hard to correct everything. It was a lot of shorts on the board. I don't know exactly what happened because I mean, even the main diode, I mean, diodes everywhere, capacitors, I mean, just name it. But luckily for him, I think this is a good repair. So I want to start from scratch. The first thing that we're going to notice is the 5-volt reference. So let me power the computer up, and that's strike one. or not even a strike one. Well, a strike one on the good side, right? Because before, remember, it was a strike one, strike two, out. But no, this is actually very good. So we got the firewall reference. I immediately can see already. Let me put the oscilloscope. We already saw the connections at first, so we don't need that. Let me get all the lines away from here. So we now see DLC2 active is going from 0 to I think it's 7 volts. Yep. Green channel, which is on DLC 12, is in 5 volts. And let me see the DLC 7 is in 5 volts too. So those will not become active until you communicate. Remember, we cannot establish auto scan. So right now that I have that, and we have the firewall reference, let's try to do a vehicle automatic scan, and we'll see that it will not connect. And the funny thing is, I don't know why it doesn't connect because when you select manually the car, it will read the beam. Let me just get the beam from American. Let me start doing this the correct way. So let's get the scanner to read that. So the last digits of the beam will be 271153. So 271153. All right, so we selected Dodge 2004 Ram truck. All right, so in here we will not see nothing until I click in here and enter. Then we will see the DLC 7 and DLC 12 become active, and which is great. Now we know that this is going to talk. And let's see if we read the beam. So 271153. 271153. As you saw, I didn't enter anything. This is the same scanner reading the beam from the computer. So why it doesn't do an out of beam, I don't know because it's there. But Joe, your computer is now working, talking. The reason we lost or not lost communication, the DLC 7 and 12 become recessive is because we're just here. In order for those to become active, you have to go into read data stream, any pit. Right now it's nothing because we're just going on the next menu. The scanner has a request any information. So let's just put the battery voltage. As soon as that is on, oh, this is the battery temperature voltage. Well, it doesn't matter. Now we see immediately how DLC 7 and DLC 12 become active. This is a good communication. So, but let me get the battery voltage because I want to make sure that we can at least see. Let me see voltage. Let's see what we got here. Fuel pressure. How is that going to have a battery voltage? I'll select. Oops, sorry, I got out of in another correct way. PCM, control module, RPM. Let me look for the battery voltage so we can change the voltage of the battery up and down. I'm not sure if we if we have it. Battery temperature, voltage, barometric pressure, ECN RPM. All right, here. See how I mean, it says battery volts. I don't know why it wasn't shown in there, but yeah, so as soon as that in there, communication is in. So I'm going to graph this. So let's make that a graph, and I'm going to change the voltage up and down as 1 volt at a time. So I went up, and we can see now that that is in 14. I'm going to go down. We're now back into 13. I'm going down more. We're down into 12 volts and back up into 13. So remember, this is BCI connected. So the scanner is requesting that information from the computer, and the computer is transferring and sending it over to the bus, and the scanner is able to read it. So that means computer is back alive, it's working 100%. We got the firewall reference. This is a successful repair. Joe, thank you so much for trusting my Salazar Diagnostics. I'm so glad I was able to help you. And yeah, I'll be contacting you shortly and send this your way as soon as possible. Thank you so much, guys. I hope you like the content. Don't forget to subscribe. See you next time. Bye bye.